Hello all, I'm going to present the uh, network intrusion detection system, Phase 2. I continue with the Phase 1 and also the same topic, and I'm going to continue this one in my Phase 2 also. Uh, Phase 1, I did identify the reliable data set. It has eight uh, different CSV files, so I contain it all together and did some data processing also, and I identify the machine learning algorithms, identify performance measures also in this one. I will show you some what I done in the phase one. Those are the things I done, and those are the machine learning algorithm I'm going to use, and those are the performance measures I'm going to use also. And also I talk about the little bit about the software defined networking in phase one. And there's a two different network intrusion detection system, NIDS, intrusion detection system, network intrusion detection system, and HIDS. And I talk about the signature based and anomaly based network detection systems differences also in the phase one. And phase two, I plan to do the basic study about modeling and how to find performance metrics. So in phase 2, I want to build three basic model using k-nearest neighbor, random forest, and gradient boosting, and then I look how they works and performs. Using those performance metrics, I wanted to find out which algorithm out of three perform best, uh, which one is perform worst, and using those performance metrics, also I want to find out which attack has highest accuracy and which attack could identify correctly also. To do that, I proposed this IDS flowchart. You can see it in here. There was a I already told there was a eight different data sets, and I append or concatenate all together and make a big data set. Then I did some data transformation. There was 80 features in that original file, so I selected 20 features using the Pearson correlation. Then I divided this dataset into training and testing dataset. First, I train the model using training dataset. Then check the performance metric using the testing dataset. Here's the initial overall model accuracy for the uh, three models. You can see the gradient boosting was the most successful algorithm when we consider only overall accuracy. Uh, However, uh, looking only at the completed accuracy for each model does not yield a precise comparison because we did multi-classification intrusion detection system are executed in here. The accuracy related to each attack type should be examined separately. We can do that using the confusion metrics. We could calculate all the performance metrics like accuracy for the each attack type for each model, and also we can calculate precision, recall, and F1 scores also, and other performance metrics also. Uh, Here are the things. Here are the accuracy for each attack by model. I will show you how did I calculate that one. Here's the here is the confusion metrics I got from the for my gradient boosting tool, and I already showed the code and everything, so I'm not going to do it in here. And benign, I will tell you guys how can we read the little bit about confusion metrics. How can we read this? True positive is the uh, each class it's going to be diagonal like this. You can identify that one, and benign for 403,000, botnet 86,000, and brute force is 108,000, DDoS 206,000, like that. And these are the true positive. You can see it in here. If I double click, yeah. And false negative is the for the class is the sum of the value in the corresponding row, excluding the true positive value. So if you go like this, all the sum of the all the row excluding this one, and false positive is the uh, for the class is the sum of value in the corresponding column, so it is this one excluding the true positive value, so it is this one, you can see. And true negative value is the for the certain class will be a sum of all columns and rows excluding the column and the row for the certain class. So we need to get all the sum of this column and rows also. And you can see there's a test data is 1 million, more than 1 million record for the test for each class, each attack. We test the same test data set. Test data set is, I want to say, 1 million, more than 1 million record. Uh, that's how we calculate. Then we can calculate the accuracy using the true positive plus true negative divided by true positive, false positive, true negative, and false negative. So you can see accuracy is depending on the true positive and true negative, right? So I want to say only considering the accuracy related to each attack type also does not give a precise comparison to, because as I said earlier, uh, accuracy depend on the true positive and true negative. I'll show you why is that. For instance, if we think about the infiltration attack like this one, uh, you can see it does has only 404 true positive and there's a 900, more than 992,000 true negative values. So that's why it's get high accuracy, because we are dividing true positive plus true positive plus true negative values with all the sum of these. So that's why it's get 0.95 accuracy in here for the infiltration attack. So why do we need to calculate true positive and recall and F1 is got true precision? Tell us what is the precision. Precision tell us how many of the correctly predicted cases actually turn out to be positive, and recall tell us the how many of the actual positive cases we are able to predict correctly with our model. And F1 score is the like tell us how precise our classifier is. It's like harmonic mean between precision and recall. So that's why we need to calculate that one. So you can see in here all the for the accuracy for the everything is like perfect for each model for the benign and we can guess like, hey, we can identify everything, but it's not because of precision, and we need to calculate precision and recall also. You can see for the k-nearest neighbor the precision is low because of we divided only true positive value divided by true positive plus false positive. And also you can see there's a 404 value only out of the all those attacks, out of only 404 classified as it is for the infiltration. All the other infiltration attack classified as benign and botnet, brute force and DDoS and DOS attack, and also the web attack also. So all the infiltration attack is classified as some other attack also. I will show you also in here, just like little example using. If we think like we need to classify and identify need 5. So there are also 5 files in here. You can see there's a 2 in here, 3 in here. There's only 3 identify as a true positive in here. And there's a 2 identify as some other classes like brute force or botnet or benign or something like that, if you think like that. And there's a one class identify it also as the number 5. It's called false positive. So if you want to calculate the recall, out of 5 only 3 three only classified as a true positives. Uh, that's the recall. I mean, how many of actually positive cases we are able to predict correctly with our model. That's the 3 out of 5. And precision is how many of the correctly predicted cases actually turn out to be positive. There's a 6 also turn out to be positive, but if you want to calculate the actually turn out to be predicted case actually turn out to be positive, we need to get these set 1, 2, 3, and 4. Out of 3 only, out of 4 only 3, uh, 3 out of 4 get the uh, actually predicted as a positive. So that's the precision, 3 out of 4. That's the all the true negative plus or true positive divided by all the other things are the accuracy. So uh, you can see k nearest neighbor, it's really low for the precision. Precision should be high, and also finance cost should be need to high to get the accurate model for the attack. All the others are fine, but infiltration and SQL injection are not give a precise identification using the k nearest neighbor. And for the random forest also, you can see everything is little bit better. Okay, I mean it's better than k nearest neighbor. Also, uh, if you go to the gradient boosting, it's also same like k nearest gradient boosting. It's also same like k nearest neighbor, and it also low. So, but other values are okay. You can see the I show you the overall attack for the accuracy. It was gradient boosting got the highest accuracy, but comparing these things, we have to come up with the conclusion. Gradient, if we only think like accuracy, we are going to give the recommended for the gradient boosting, but we can't do that. And also, uh, I show you botnet and all the other things has the highest accuracy. If we compare only accuracy for each attack type, it's like all the things are 100% botnet and SQL injection and web attack also got the everything 100% for the gradient boosting random and k nearest neighbor. And all the attack also greater than 90% accuracy. So, but we have to consider the precision, recall, and F1 score also. So, the recommended one is the for the intrusion detection system is random forest algorithm out of these three algorithm. And future works could be like we can do the hyperparameter tuning and increase the precision, recall, and F1 score. Also the accuracy also we can do that using handle data imbalance. Also we can do that and normalize the data set also increase these values. And finally we can after we train the all the things, and after we make the model, we can check the performance for the other data set also using the train data set. And these are the citations uh, I included in my paper. Thank you very much.